What's up, guys? Another day, another lock-in. Today, I will be doing some board rules for the chess game. For the chess game. Actually, yeah. Okay, I'll do what I can. I'm being called upon, but I'll do what I can. Uh, 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 uh. Ites. Wait, okay, so this, what's wrong with that? And then board rules. How do I merge? So I go to Troy. I go here, choose a branch to merge into Troy. So now this should be okay, sick. Generation is in check. So what I want to do for this is loop through board. Loop through board to find the color of king. Loop through enemy pieces, and then if any if any enemy any enemies get valid moves board has the king's position return true. Find king. Okay, to find the king, king underscore position is equal to none right now. For R in range 8, because that's how big the board is. And then for C in range 8, because that's the X and the Y. Piece equals board R C. P E. I spelled piece wrong, of course. P-I-E-C. So then if P if piece is not none, and piece dot color is equal to color, and is instance piece piece king, king pos is equal to RC, and then you break. And then if king pos is none, return false. Bang. Oops. check if enemy pieces attack king. Enemy enem ene, enemy color is equal to black if color is equal to white, else white. Then for it's gonna be the same thing here. Might as well just copy it. Range 8. Piece. Oh my goodness. Piece. It's the same as this whole thing. There we go. Hold on, guys. Hold on. Wagwan. Wagwan. Wagwan brethren. Okay. So piece piece equals board. See. Then if piece is not none and piece dot color is equal to enemy color. If hmm if king if king pass in piece dot get valid moves board none return true. Return false. So in x and y, piece equals x and y. If piece is not none, and piece color is equal to enemy color. If the king pos if the king's position is in the valid moves, return true. If uh, checks if the piece is valid and is the enemy. Checks if the king is valid if okay. I should do square attack next. How long have oops, do not listen to that. How long have I been streaming for? Only 20 minutes? Okay, I can do this one next. So what this does is it returns true if a square square is is by a piece of by for R it's just this again. Wait, did I do this right? Piece border, C, yeah. But for this one, it would be for on range a piece equals self dot board RC. Piece is not none and piece dot color dot color if row call in piece dot get valid moves self board none. Oops. Return true, then if not, return false. Not the same. Text. Yeah, because it's it's checking if is square attacked, so it's checking if this square is attacked by a from a row, a column, and by the color attacking it. Okay, so this is done. Let me push this. What should I do next? Move generation. It's only been 30 minutes.
Congratulations, Jeremy. Big things ahead in your future. I cannot wait to see what you do. Candle? No, a shining star.
Okay. Okay. First thing to do. Player has a list of piece, row, call, tuples. So moves equal to this, a list. For row in the board self dot board. For piece for piece in the row, if piece is not none and piece 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 dot color is equal to the color. Did I mess this up? Piece is not none. Is not none. Okay. Yeah, but I mean, whatever, man. For move in self dot get piece valid moves piece moves dot append piece piece move shoot move move return move moves. Bang. Okay. So this sets it as a list for row in self.board. So for every row in self.board, and then for every piece in that row. Uh, Colored match. Wait, what the heck? Why is the IDE so big? I just realized. Sorry, stream. Sorry, chat. Let me see if I could fill this in. That should cover the whole stream now. Then if it is valid and this is for every move. Every move in moves add to the list. The piece, the and its row and call. Now I should do get piece valid move. Returns legal moves for a piece excluding moves that leave the king in check. So let's make it raw moves. So raw moves is equal to, so the raw moves basically just gets all the moves. Get piece. So piece dot get valid moves self dot board self dot en passant target. Then return move for move in raw moves if not self dot leaves king in check piece piece move 0 move 1. So what this does, this is all moves returns moves that don't check. Added all Why is it so big? What should I do now? What should I do now? How long have I been streaming for? 49 minutes. I have some time. I'll probably do this. In checkmate is in stalemate. Okay, time to go back in. So, isn't checkmate? Return self dot is in check color, and then self dot board and length of self dot get all valid moves of the color 0. If then isn't stalemate. Uh, Return truth, no legal move exists, but not check. Return if it's not self dot is in is is in so is in check, so it's not in check. Color self dot board and the length the length of self dot get all valid moves of the color is equal to 0. If if player isn't in check but has no valid moves, return true. Added is Alright. It's been an hour? Hmm. Alright. Moving on to the uh, to this. To Ohm's law. I already learned about Ohm's law, but
Ohm's law. Every electronic device is composed of circuits and circuit boards. In order for these devices to work correctly, electrical engineers need to precisely understand and control the flow of electricity. Known physical laws determine how electricity behaves in a circuit. In this lesson, you'll explore one of these laws, Ohm's law.
Ohm's law. Hold on, guys. Gonna clean my glasses real quick.
Overview. In this lesson, you'll learn about Ohm's law. You'll also build series and parallel circuits and investigate how electrical measurements such as voltage behave in these circuits. Using a tool called a multimeter, you will measure voltage in the circuits
Multimeter.
you build. Learning objectives. Relate schematic diagrams with actual circuits. Investigate the relationship between resistance, current, and voltage in a circuit. Use a multimeter to measure resistance and voltage. Construct series circuits and parallel circuits using a breadboard. Compare how voltage
Series
behaves
and
in series
parallel.
circuits versus parallel circuits. Vocabulary. Conductance, a measure of how easily current can flow through a circuit. Multimeter, a device used to take multiple electrical measurements. Parallel circuit, a circuit where components are wired in such a way that there are multiple paths for electricity to flow through. Schematic diagram, a representation of a circuit that uses graphical symbols to represent each component. Series circuit, a circuit where components are wired one after the other, forming a single path for current to flow through. Wiring diagram, a representation of a circuit that uses pictures to show how components in a circuit are connected.
Wait, hold on, guys. Alright, chat. Shit. There's that. Then let me get my multimeter out. Whoopam, whoopam. Get these cables out with the multimeter. Alright, chat.
External LED activity. So far, you've learned about 3 basic measures of electricity voltage, current, and resistance. In this activity, you'll create a simple circuit with an LED. You'll then use a multimeter to measure voltage and current in the circuit. You'll calculate the
Excuse me.
resistance in the circuit using Ohm's law.
Components needed: the Arduino board, 220 resistor. In my note, I have it in my notes what the 220 is. 220 is red, black, black, brown. I need the battery. Let me grab a red LED. Red LED. It's this one. The battery snap. Where's the cap for this? Whoa. Oh, it fell. Okay. Schematic diagrams.
Schematic diagrams. Often, trying to understand how a circuit is put together from a picture can be quite difficult. Components can be very tiny and hard to see. It can be a challenge to know what is connected to what. When engineers, electricians, electronics technicians, or other people who work with electronics need to communicate how a circuit is put together, they often use a schematic diagram. A schematic diagram is a representation of a circuit that uses graphical symbols instead of pictures of each component. These symbols are connected by lines that represent wires or conductive paths for current to flow. Each type of electrical component has its own symbol. Although the symbols might differ in some parts of the world, they are generally recognized and used by most electronics experts to communicate the design of a circuit. Shown here are few symbols of components you've used so far.
I remember using resistor and battery in one of my classes. That's the one you could assemble. Battery to the resistor, then to the LED, then to the battery. In lesson 2, you'll start with a similar circuit. However, you'll power the circuit with an Arduino board, but the In lesson 2, you'll start with a similar circuit. However, you'll power the circuit with the Arduino board. But the Arduino board is different from other electrical components. It is an entire system of components in one device. When representing this kind of system, which is made of multiple parts, do do all the parts, resistors, LEDs, processing chips, and everything else that make them work need to be represented in a schematic? The answer is no. Systems like the Arduino board usually don't have predefined symbols because every system is different. However, you can use generic symbols to represent them. What is important is in the what is important in the schematic is to show how the system is wired to the rest of the circuit. If you were to replace the battery in the circuit from lesson 1 with the Arduino board, the schematic might look like this. I see. A wiring diagram is another way to represent a circuit. The main goal of a wiring diagram is to show the components of a circuit, show how the components in a circuit are wired. The circuit of the schematic diagram above might have a wiring diagram that looks like this. Oh, so it doesn't have to go around the whole board? It's, I see. Okay. Okay, as long as it goes to the positive to the negative terminals. Interesting. Interesting. Build a circuit. You can see if you can build a circuit from this schematic diagram and wiring diagram. If you run into any trouble, use the following slideshow to build the circuit step by step. So you have this from the positive. So this third one to, what is that? 2. So like that. And then you have the red LED going from here to here. Okay, it's lying. I do need one of these. This may need to be too big. Could be one of these. No, this is too big. Loki, let me put that here. To the negative. This is wrong. This should go to the 4. Like that. I need long ones. Let's say these. 13 to the plus. and then minus 2 D. What is this? G what? G and D? Oh, there I made the circuit. Oh, 2D. 2E to 4E. Sugar wire to the ground. 4A. It's to 4B. Doesn't matter. Oh yeah, it's negative then plus. Thirteen. Open the Arduino IDE. Examples, basics, blink. Wait, what does it say? Examples, file, then examples, then basics, then blink. Let me connect it. Tools, tools, board, Arduino, no. Tools, board, Arduino Uno, tools, port, com, tools, port, com, delay, 10,000, delay 3,000, 30,000, I mean. Upload, Change them both to 3. That's cool. If you guys can see it, it's lighting up for 3 seconds and then turning off for 3 seconds. Man, multi-hooters.
Invention Spotlight. Measuring electricity. It is said that necessity is the mother of invention. But in a pinch, annoyance can work too. In the early 1920s, an engineer named Donald McAdee was experiencing some frustration at work. He was a senior engineer at the British Post Office. One of his duties was to inspect telecommunications circuits used for sending telegraph messages. He looked for faults in the current carrying circuits. But he was fed up with carrying around different pieces of equipment to take different measurements. He worked to design a single device that could be used to measure amperes, voltage, and ohms. He created the world's first aviometer, a device that could be held in the hand. Can you guess why it was called an aviometer? Hint, the name relates to the three things it measured.
The amperes, voltage in ohms, aviometer. Wow, very clever. Very clever.
McAdee registered for a patent with the British Patent Office, and it was granted. He and others formed the Automatic Coil Winder and Electrical Equipment Company to manufacture and sell the device. The first aviometer was a mechanical device that used a moving needle on a dial to display its measurements. Over the years, improvements were made. As other companies made similar devices, the generic name multimeter came into use. Multimeters today often have many additional capabilities, and most are now digital. However, there are still uses for analog versions.
Coolio.
Multimeters. A multimeter is a device used to take multiple electricity-related measurements. Most multimeters can measure voltage, current, resistance, and continuity. Locate your multimeter along with the red and black test leads. Make sure the multimeter is in the OFF position. Insert the black test lead into the COM port of the multimeter. Insert the red test lead into the voltohm milliamp port.
Yo, how do you turn this thing on? Yo, this thing is not turning on. Okay, well. Volt ohm milliamp. Okay, I have it. Well, bam. That's what it looks like in the image.
You use the dial on the multimeter to select what type of electrical measurement you want to make and the range you want to measure. Generally, you want to use the range that will give the most precision without going over the maximum value.
His? Hello?
In this image, the settings shown are for measuring voltage with direct current. Voltage is indicated by the capital V. Direct current is indicated by the symbol that has a straight line over 3 dashes. Your multimeter has 5 different DC voltage ranges: 200 M, 2V, 20V, 200V, and 600V. These numbers represent the maximum voltage that can be measured on each setting.
Three dashes? Straight line. Oh, I see.
For example, to measure the actual voltage of a 9-volt battery, you can't use the 200 M or the 2V setting because the 9-volt battery has a voltage that is higher than the range of those settings. A 1 will appear on the multimeter, indicating the voltage is out of range. However, you could use the 20V, 200V, or 600V setting because 9 volts is less than the maximum range. The higher the measuring range, the less precision there will be in the reading. Of these 3 ranges, the 20V setting will provide the most accurate measurement.
Oh, oh.
Oh, I see. Okay. Multimeter has 5 different DC ranges, so from here to here. Oh, so this is AC. Okay. Squiggly line. DC? Direct measurement. So this is voltage DC. This is voltage AC. Doing our board. So you won't use this setting. So, okay. So I won't even use this. The following arrange the setting. Your multimeter has a
The Arduino Uno R3/R4 board provides direct current, so you won't use these settings in this course. In the following image, the settings for measuring current is shown. Your multimeter has a 200 μ, 2 m, 20 m, 200 m, and 10A setting. For measuring current less than 200 milliamps, you would plug the red test lead into the voltohm milliamp port. Then, turn the dial to one of the milliamp settings. For measuring current up to 10 amps, the red test lead must be plugged into the 10 ADC port. Then, turn the dial to the 10A setting. You should not need to use the 10A setting or port for this course. To measure current in a circuit, the multimeter must be inserted into the circuit. In other words, it must become part of the circuit. This is different than measuring voltage or resistance that can be measured across a component in the circuit. You'll have a chance to do this a little later when you start building circuits. Note, if you don't know the current, start with the 10A setting. If it shows that the current is less than 200 milliamps, you can then switch to the 200 m setting. The HFA NPN PNP setting is for measuring transistors. You won't use this setting in this course.
Wait, what? Do I need to read this again?
For measuring current less than 200 milliamps, you would plug the red test lead into the voltohm milliamp port.
Mm-hmm.
Then, turn the dial to one of the milliamp settings. For measuring current up to 10 amps, the red test lead must be plugged into the 10 ADC port. Then, turn the dial to the 10A setting. You should not need to use the 10A setting or port for this course. To measure current in a circuit, the multimeter must be inserted into the circuit. In other words, it must become part of the circuit. This is different than measuring voltage or resistance that can be measured across a component in the circuit. You'll have a chance to do this a little later when you start building circuits. Note, if you don't know the current, start with the 10A setting. If it shows that the current is less than 200 milliamps, you can then switch to the 200 m setting. The HFA NPN PNP setting is for measuring transistors.
Just realized
You
there's a
won't
screw
use this
back
setting
here.
in this course.
This pen really comes in clutch. If you guys go to San Francisco or Alcatraz, you should buy one of these pens. It's pretty sick. They last a long time. Plus, you could buy refills, and then it has a screwdriver plus it has a Phillips plus a flathead. It has a level, a clip. It's really sick. Man, this thing smells like rubber. It smells so much like rubber. Oh, I have to take off the plastic. Ugh, smells bad. Bro, there's rubber literally like stopping it from. Does it tell me? Okay, because like, it doesn't tell me how to add the battery. It's so messed up. And then it's telling me to like multimeter. Yeah, let me just finish reading this. So, let me finish reading this, and then off camera, off stream, I'll see what batteries this takes in. For measuring less than 2 minutes, so use this, that one. Measuring up to 10 amps. Yeah. Plug into the 10 ADC port. Yeah, okay. To measure a current in a circuit, the multimeter must be inserted into the circuit. In other words, it must become part of the circuit. It's different from measuring. Yep. Since across voltage. The setting the setting with the diode symbol and the sound icon is used to measure continuity. When measuring continuity, the multimeter will beep if current can flow between the test leads. So it's this one. The last
This last group of settings is for measuring resistance. Resistance is indicated by the Greek letter omega. Multimeters usually have multiple settings for measuring resistance. Your multimeter has 5 settings: 200, 2K, 20K, 200K, and 2M. These numbers are the maximum value that each setting can measure. Use the range that will give the most precision without going over the maximum value. As you measure resistance, voltage, or current, the display might fluctuate a bit. You can use the hold button to stop the fluctuations and save a reading. The reading will remain on the screen until you press the hold button again. Reflect on this. What multimeter setting would you use to measure the following electrical values? 12 volts DC, 220 ohms, 25 milliamps, 220 volts AC.
12 volts, 12 volts, so that would be the 20 volts DC ohms. Milliamps, 25 milliamps would be, because it's 200 right here. 25 milliamps. 25 milliamps 220 ohms. What is 220 ohms? Which one's ohms? Oh, 220 ohms would be 2K here, and then volts AC would be here. Alright, well, this is goodbye for now, chat. Oh, fuck, I dropped the screw, no! Ah, shoot. Okay, whatever. Okay, this is goodbye for now. Goodbye for now, chat. I will, um, shoot. I dropped the screw. That sucks balls. Oh, I found it. Okay. Goodbye for now, chat. I will continue this probably not tomorrow. I'm going somewhere tomorrow. So, I might, not, I'm probably not going to stream tomorrow. It's very unlikely if I do hop on because I'm going somewhere with my family and friends. So, don't expect the stream from me tomorrow for Saturday. Maybe Sunday. That's like a hard maybe. It's always hard maybes on weekends, especially Sundays. But all right, that's goodbye chat. Uh, I'll see you guys probably most likely Monday for sure Monday, but this weekend probably not. All right. I'll see you guys